Chapter 2, Section 3, Properties of Minerals. So we've already spent some time talking about elements and minerals and how minerals make up rocks. Well, today we're going to talk about specifically some properties that can help you identify what a mineral is. So in order to classify a mineral, we're going to do that by composition. And all of these properties are going to help determine a specific mineral group. Okay. And all of these can be found in different groups based on their properties. So the first one we're going to look at is the color. And color is actually not the best property to use to identify a mineral, simply because small amounts of different elements can give the same mineral different colors. So for example, quartz can be more than one color. All of these that you see here in this image, all of these are sapphires. Okay, not all sapphires are blue. So just because it's one color does not mean that it's a sapphire or does not mean that it's a diamond. You can have pink diamonds, blue diamonds. You can even have chocolate colored diamonds. Okay, so color is really not the best property to use, but it is a property available. A good one that you can use is streak, and that's the color of a mineral in its powdered form. So if you were to take one of those minerals or a rock and you were to rub it against a porcelain plate, what we call a streak plate, it's going to leave behind this powdered color. That powdered color is what we call the streak. Every mineral has its own streak. So for example, if you look at this middle image, red hematite has a red streak. Okay. Whereas white calcite has that white powdered form. So you can tell the difference between the two based off of their streak color. Another property is luster, and that's how light is reflected from the surface. So it can be completely reflected, or it can be absorbed, so not reflected at all. So we have what we consider to be metallic lusters or non-metallic lusters. And obviously all the ones you see here are quite metallic. Another property is crystal form. It's the visible expression of the internal arrangement of atoms. So what it looks like on the outside is how it's arranged on the inside. So the galena cubes has a cube-like structure. The hexagonal beryl, that has a hexagonal structure. Okay, so each of those represent their internal structure on the outside. So it's very visible to us. Another property is hardness, and that's a measure of resistance to being scratched. So the harder it is to scratch an object or scratch a mineral, the higher it is on the hardness scale. Okay. So think about something that's really easy to scratch versus something that's not. And there's actually a scale for this. It's called the Mohs scale of hardness. There's 10 minerals that are arranged on this scale. They go from 10 being the hardest to number 1 being the softest, and I have that scale here. So the one that is number 1, the easiest to break down, is talc. Now, do any of you know what talc actually is? Talc is what you find in baby powder. So if you think about baby powder, I don't know if you have any younger siblings, but baby powder is something that's very soft, very smooth, almost like a greasy feel to the touch. Moving on down, take a look at number 3, calcite. If you think about calcite, I don't know how many of you know what that is, but calcite is similar to your fingernails. So that's a 3. So think about how easy it is to cut into or to scratch your fingernail. Okay. So it's actually pretty easy to do. Moving on down the list, number 7 is quartz. And in between quartz and feldspar, 6 and 7, that's where glass, like the glass in your windows or the glass on a vehicle, that's where that lies. So it still can be scratched, but it's a lot harder to do so. And then, of course, all the way down at the bottom, number 10, the hardest substance and one that's almost impossible to scratch is diamond. Another property is what we call cleavage, and this is how a mineral cleaves or breaks in flat, even surfaces. So think about mica. That's going to cleave into flat, thin pieces or sheets as it pulls apart. Other things might be calcite or halite. One of those where you break it, it cleaves off into these specific shapes. So it could be a cube, it could be a hexagonal shape, something like that. If it's not cleaving, it's actually being fractured. So here are some examples. The first one is muscovite or mica. So it's cleaving in one direction in sheets. Excuse me. You can also cleave in two directions, which is like feldspar. So it's going to have this perpendicular plane. Three directions, halite, that's what we were just talking about. Halite is table salt. And then if it's two directions but in a different way, so kind of on a diagonal, you have calcite. Okay. So again, fracture, this is what happens if it's not being cleaved. So if it doesn't have cleavage, that means it's fracturing. So when it breaks, it's not this nice, even, square, rectangular, diagonal, or sheet-like shape. It's uneven. So it will break in more than one place, and quite often it will leave behind this kind of smooth, rounded shape. And that smooth, rounded shape is what we call a conchoidal fracture. So it almost looks like a conch shell from the beach. It's got that rounded shape with those nice lines to it. Density is another property. It's the ratio of an object's mass to its volume. And you can discover what density is, especially with objects like these, by using that displacement that we talked about in chapter 1. So for today, I want you to read 2.3 from the Earth book and 13.3 from the environmental book. We will have lesson 11 handout, which goes with mineral properties, and then we will have a North Carolina minerals lab, hopefully. And that's it for today.